Okay, hello. We're going to look at a simple relative motion problem that was on your exam. You're told that you're running relative to the Earth at 8 meters per second northward. So we'll draw that as this arrow right here. And we'll put that in terms that we understand from our relative motion stuff. So velocity of, u relative to the Earth. So let's say y, u, and then Earth relative to the Earth. And we're told that that velocity is 8 meters per second in magnitude and pointed in the direction we've got. Okay, and you feel a wind, so the air's velocity relative to you, 6 meters per second south. And I go on to sort of explain, like, okay, that literally means a vector pointing south rather than a south wind, which would mean the air was moving from the south to the north. Anyway, yeah, I didn't want any confusion there. So what we've got is 6 meters per second south, and that's going to be something like that. Okay, and that's the velocity of the air relative to you. That's what you're feeling. So V sub AY, air relative to you. And we're told that magnitude is 6 meters per second. And you are asked, what is the true wind speed, i.e. the air's velocity relative to the Earth? So what is the air's velocity relative to the Earth? Okay, magnitude and direction. Okay, so you can probably use your intuition on this one and figure it out, right? If you are just running along and there's no wind at all, you would feel a wind in your face that's equal to your velocity relative to the Earth, but in your face, so in the opposite direction. But here we're seeing or feeling something less than that, so we're expecting a tailwind of a small amount. But let's put it in the terms that we have used for relative motion. And that tells us that we have this equal to that plus this. Right, again, these little subscripts for the one that we don't see over here, sandwiched by A in the first position, E in the second position. And you see that over here as well, okay? So if you have that pattern, you know you're doing the right sum. In terms of what it looks like on the diagram, well, then you'd sort of move this so it's to the head of this one. And you draw it down like that. So there's V air relative to you. And that means that the sum is just the origin, right, connected to the head of that second vector. So it's this vector right here. That is V air relative to Earth. Sorry, that's a little small, okay? And so what that looks like in terms of this equation is just that you've got air relative to u, which is negative 6 meters per second. You've got u relative to the Earth, which is positive 8 meters per second. And so this velocity is 2 meters per second north in our coordinate system here. Okay, so in other words, it's a tailwind coming from behind you, and that's why the apparent wind that you feel is a little less than your own velocity. Okay, so that's that. On to the next one.